So there are two possible conformations that result from the free rotation about the carbon-carbon single bond. We mean this one where it's blue. Basically, if you rotate this single bond, you can actually get a conformation that's called S-trans, where the double bonds are on opposite sides, they're trans to each other, or S-cis, where they are on the same side, cis to each other. It's helpful if you take a look here. So this is the same compound that we drew, or this is an example here. If you notice that we have this single bond right here, single bond, that's where the S come from. So we say S. And if you notice here, the double bonds are on the same side. Or the H's are on the same side on that single bond. So that's called S-cis. You can draw the trans of this molecule. So if we were to number this, we would say this is 1, that's 2, that's 3, that's 4, that's 5, and that's 6. Let me use a different color. So if I just put the double bonds, and that would be 1, that would be 7. So here it is, 1, 2, 1 and 6, I mean. Not sure where 7 came from. 3, 4, and 5. You would notice that this is an S-trans. One way is this would be helpful is if we draw the H's on that single bond. So it's this single bond that's between the double bonds, and you see the H's are on opposite sides. So this is called S-trans. So you should be able to draw this as well. So make sure you do this. You can pause and draw the S-trans of this. So this is S-cis. Should be able to draw it. We prefer the S-trans. The S-trans is more stable. Simply because of the sterics. So this is a more stable conformation due to sterics. And generally the sterics, I'm going to mention this really quick, is between these two H's are these electron clouds, and the H's are repelling each other. So that's causing a steric strain. Similar to this as well. However, so as we said, most conjugated dienes prefer the S-trans conformation, but there are exceptions, and the exceptions such as these right here. If you notice, these molecules, these two molecules, will be used later in the chapter in the Diels-Alder reaction. And the reason why they're preferred, of course, due to the sterics as well, and as well as the reaction. The reaction goes faster when they are in the S-cis conformation.